So we're now moving on to our next unit, so Unit 3, and we're going on to the first section or first part of this unit, so it's Unit 3A. And all this video is meant for you to do is to be able to identify like terms. So we're just identifying like terms in this video. So our learning objective and what our goal is for the end of this video is that students will know what a term is. So first off, in order for us to identify like terms, we need to know, well, what is a term? And then students will be able to identify like terms, right? So at the end of this video, you should come back to these learning objectives and see, do I know how to do these? And in this way, if you do, you can check it off. And if you don't, it's something that you can use to help come into class with a question and say, I didn't understand this learning objective. Can you clarify it for me? All right, so let's go ahead first and define what a term is, and then go over some examples of terms and then what are like terms. All right, so now we need to ask ourselves and define, well, what is a term? And a term is a single mathematical expression. So it's a singular. So we're looking, when we say a term, we're only looking at one. All right, and it can appear in a few different ways, and we're going to go through all of these and an example of each. All right, so it can be a single number. So when we talk about a term, it could just be the number 5, or it could be the number -6, because it could be positive or negative. But when we're looking at a term, it is a single mathematical expression. So a term can just be a numerical value, right? For part B, it can also be a single variable. And remember, well, what is a variable? A variable represents an unknown. So it's a number that we don't know. And it's usually denoted or represented by a letter. And it could just be just a single variable and just a letter, let's just say X, what you might be used to seeing. Or it can be an X or a variable that has any exponent. So it can be, let's say, Z to the 5th power. Both of those are considered to be terms because we're looking at a single expression. And essentially, it's representing just one number. Even though that Z might be raised to the 5th power, when we multiply that, it would give us just one number. Right? The next thing that it can represent, or the way that it can be represented, it could be several variables that are multiplied together, but never added or subtracted. And we'll explain that later on. We'll come back to that at the end of this little part of the video. But it could be several variables that are multiplied together. We can have x, y, or we can have negative a, b, c. Right? So in this case, we have multiple variables that are being multiplied together, but they're never added or subtracted, meaning the variables aren't added or subtracted. All right, so just like we did before, where it could be a positive or negative number here, our variables can both be positive or negative, but they would have to be multiplied together. And then the last example that we'll go through is it could be a number multiplied to a variable. So let's say 3x, or it could be -2y. And in both of these cases, the number that's being multiplied to the variable, so this 3 and this -2, we have a specific name for them, and they are called a coefficient. So if you hear me or anyone talking about a coefficient, it is the number that is being multiplied to our variable. All right, so now all of these are representing different terms because they're all singular. All right, but we don't always have expressions that just have one number in it. So we could actually have multiple terms that are added together. So let's just go through an example of that. Right, so if I were to take the first one of all of these, so let me just go through and highlight them all. So the first one I wrote, first example for all of these, and I were to combine them all together and write them as one expression, so 5 plus x plus xy plus 3x. In this case, I actually would have 4 different terms. All right, our terms are also expressions that are separated by a plus or minus sign. So this would be one term. This would be its own term. These would be its own term. And so would this one here, because they're all being separated by these addition or this minus sign that we have. And that's why this had this very important detail to add, that they can never be added or subtracted, because instead of multiplying this ABC, if we were to say -a plus b plus c, well, we're actually looking at 3 separate terms there. So by multiplying them, it then gives us one term instead of looking at them as 3 separate. Right? So a term is a single mathematical expression, and we can combine them through addition or subtraction to have multiple terms in one problem. In this problem here, we would actually have, the way it's written, we would say that we had 4 terms, but once we learn how to simplify, there would actually be 3 there. But just remember, when they're separated by these addition or subtraction, they actually would represent their own single term. All right, so a term is just a single mathematical expression. So now let's go through identifying what like terms are. Before moving on to like terms, actually, let's just go through these. When we just have a number and no variable, they are referred to as constants. So if you hear me talk about a constant, it is just a numerical value that doesn't have a variable multiplied to it at all. So it's just the number that we have. All right, so it's important for you to know that when we talk about this next part of like terms. All right, so for this, what are like terms? And like terms are terms that have the exact same variable or variables. So meaning if we have multiple variables as part of our term that are multiplied together, every single variable must be the same. And all those variables have to be raised to the exact same exponent as well. All right, constant terms are like terms. So if we have a number, just a number, they are like terms. So if we look here, 3 is a constant. And all these other in our first row have a variable being multiplied to that number. So even though we see a -2 here, the 3 and -2 are not like terms because this 3 is just a constant. And this -2 is the coefficient or being multiplied to the x. So you see we have a variable here, this x, that we don't have with this 3. So they're not like terms. In order for terms to be like terms, they need to be identical in every way as far as our variables are concerned. Right? So in this case, this 3 and this -8, they are like terms because our constant, they're both constants. It doesn't matter if our constants or coefficients match. It just matters that if they are a constant, then they are like terms. All right, so when we move on to this blue one, even though I see that this blue term is -2x, this is not the exact same as this 4x squared because this green term has a square. So even though that they both have a variable, x, the same variable, their powers are not exactly the same or their exponents are not exactly the same. So they are not like terms. All right, so if we look down here though, I see we have a -10x here. Well, this -10x is a like term to our -2 because our variables are exactly the same. They're both a variable of x. They're both being raised to the first power. The coefficients don't need to be the same. And when we're going to learn in the next video of what we do with those coefficients when we combine our like terms. But in order to identify that they're like terms, the variables must match exactly. So in this case, they both are just an x being raised to the first power. So once again here, I see that I have an x here and an x, but this one has a y, this one is x squared, which doesn't match the x. So I know that that's not a like term with my red term that I have here. So it can't be the same because they are not identical. But if I look at the one below it, these are like terms because our variables are exactly the same, right? They are both x squared. It's the only variable that we have, and they're both being raised to the first power. Remember, our coefficient doesn't really matter if they're the same or not. That's just what we will actually do when we go ahead to multiply or add and subtract. That's telling us how many of these x squares we have, right? It's actually telling us that we have 4 of them. And it could look like this, but instead of doing multiplying, these would be adding. Instead of adding these 4x squares together, we can then rewrite that as multiplication to represent 4x squared. Remember, it's just telling us how many of these x squares that we have. We have 4 of them. In this case here, we can also have the division there, but we can also look at this as 1/16 times x squared if we really wanted to. But all we're doing is just identifying, are our variables exactly the same? Do they have the exact same variable with the exact same powers? All right, so then for this next one here, we know that these two are not like terms because even though they both have a y, this is raised to the 5th power. This term has an x in it that this one is missing, so they're not the same. So we know that they're not the same there. However, when we look down here, we see that our variables are both x, y being raised to the 1st power. So those are like terms. What do you think that 8x squared y is a like term to this term that we were just talking about there? All right, and then our last one that we're going to go through here before we move on to the next video, because all this video is just talking about our like terms, is here we have y to the 5th power, here we have y to the 5th power. So those are like terms because they have the exact same variable or variables raised to the exact same power. And for this one, I just wanted to just talk about when we don't write a number in front of there, it's understood to be a 1. So even though that's not written, this is understood to be a -1 y to the 5th power. So we don't ever have to write the 1 in front. It's understood to be there. And that's how here it wasn't written, and this 1x squared is how we could rewrite it as 1 over 16 times x squared if we wanted to. All right, that is it for this video, and we're going to move on to the next video of combining like terms after this.